In this video I'm going to be talking about LU decomposition. Often known as LU factorization in some textbooks. So what we have with LU decomposition is we have some square matrix A, and I want to factorize that into two matrices L and U. So L is a lower triangular matrix, U is an upper triangular matrix. So what I'm going to do is I'm going to have a look at a 3x3 example. Okay, so we're not choosing too large of an example. So I'm just going to write down a 3x3 matrix with the A elements. A1, 3, A2, 3, A3, 3. Okay, so I want to factorize this into two matrices. So the first matrices I mentioned is going to be lower triangular. So I'm going to have L11, L21 and L31. I'm going to have a 0 because that's an upper triangular element, so that's an upper triangular element there. L22, L32 and two zeros and L33. Okay, so that's my lower triangular matrix. Now for U, which is going to be the upper one, so I'm going to have a U11 because this is an upper triangular element. I'm going to have U12, U22, 0 and U13, U23 and U33. Okay, so that's what we have. So we have, if we count up the number of L's and U's here, we have 12 unknowns. So these are what we have to calculate. And if we look at the number of elements in A, we've only got 9. So we've got 9 elements in A. So if we wanted to calculate a unique values for L and U, we couldn't do it because essentially the number, we've got 12 unknowns and we've only got 9 elements. So what we do is we let our main diagonal elements of L, Lii, equal 1. So essentially, so this is going to be 1, that one's going to be 1, and also that one's going to be 1. Okay, so that reduces the number of unknowns by 3. So therefore we've got 9 unknowns and 9 elements in A. Okay, so if we were to if we were to multiply L and U together, okay, so we'll have 1 times U11. If we go down to the second column, we'll have L21 times U11. And we'll have L31 times U11. Okay, and going across to the second column, so I'll have U12. Second row, second column, we'll have L21 times U12 plus 1 times U22. And finally on the third row, we'll have L31 times U12 plus L32 times U22. And finally for the third column, we'll have U13. We'll have L21 multiplied by U13 plus 1 times U23. So that's it, plus U23. And finally we have L31 U13 plus L32 U23 plus 1 times U33. Okay, so there are 9 elements, okay, in L times U, and they're going to be equal to the corresponding elements in A. So if we start with, if we take the lower triangular elements, okay, so if we look at the elements of L, okay, for a given element in A, i.e. Aij, okay, what we have is we have the sum of k equals 1 to j of Lik times Ukj. Okay, so just pick one of these. Let's pick I is 3, j is 1. So we have Li1 times U1 2 Okay, because remember a 3, so if we're taking I as 3, J as 2, so K goes 1 to 2, plus L 3 2, U 2 2. Okay, so you can see that there. So what we can do is we can do a little trick here, and we can take out one of these. Okay, so if we take out one of these, we have Lij Ujj plus the sum of K equals 1 to J minus 1. Okay, so we've taken out the last term in the summation, and that's Lik Ukj. Okay, if we rearrange this, what this gives us is Lij is 1 over Ujj. Okay, so that's dividing throughout by that term, multiplied by Aij minus that summation. Okay, that's Lik Ukj. Okay, so that's how we calculate an element of L. Now if we look at the upper triangular matrix, we've got something similar. The upper triangular matrix Aij. Okay, so let's take this element here. You can see we've got U33, which is Uij. Okay, so we've got Uij plus the sum of K equals 1 to I minus 1 Lik Ukj. Okay, so that's quite similar. Okay, so that gives us our upper triangular element. If we rearrange that to make Uij the subject, we have Aij minus that summation, so K equals 1 to I minus 1 Lik Ukj. Okay, so we're going to use equations 1 and 2 to calculate U and L in our LU factorization. Okay, so just going to go through an example. Like most things, it's always better to have a look at an example, and the example we're going to go through example 6.1 in the notes. 6.1. Okay, so in example 6.1 we have our A matrix. It's a 3 by 3, so it's 1 2 minus 3, 3 minus 4 1, and 0 minus 1 2. And I'm just going to remind us about how the LU calculations. So L was 1 over Ujj Aij minus sum of K equals 1 to J minus 1 L Ik Ukj, and for Uij it was, just to remind us, is Aij minus the sum K equals 1 to I minus 1, and same thing Lik Ukj. Okay, so that just to remind us what we're calculating. Okay, so what we do is we go down each column in turn. So first I'm going to do the J equals 1 column. Okay, so U 1 1. Okay, so when J is 1, we've got I is 1. Okay, so we've got A 1 1 minus this summation, but K goes from 1. I'm just going to tidy up that summation. So K goes from 1 to I minus 1. Well, in this case I is 1, so we don't have a 0 term, so that's just going to be A 1 1, and in this case it's just 1. So when we go down, okay, I've finished with the upper triangular element, so now this 2 is in the lower triangular region, so now I'm calculating L21. So if we use this, missed off a bracket there, we use this, we got 1 over U11 multiplied by A11, oops, a bit premature with that close bracket, minus this summation, but of course J in this case is 1, and so this sum doesn't really exist. Okay, so we just calculated U11 to be 1 times, that should be A21, shouldn't it? Sorry, so that's Aij, so that's A21. So that's 1 over 1 times 2, which is of course 2, and L31 is 1 over U11 times A31, but it gets still J is 1, so this summation doesn't exist. Okay, so we've got the first column. Okay, let's have a look at the second column. So U12, so this is an upper triangular element, so U12 is equal to A12, which is equal to 3. This is an upper triangular element because we've assumed that L22 is 1, so we need to calculate what U is for this element here in the second row, second column. So U22, so using this, is A22 minus sum of k goes from 1 to I minus 1. Well, in this case I is 2, so we've only got one value of k, and that's 1. So that's L21 times U12. Okay, so that was equal to A22 is minus 4 minus L21, which we've calculated to be 2, so that's here, multiplied by U12, which is 3. So that's minus 4 minus 6, which is 10. And L32, so we're looking at this element now, which is in the lower triangular portion of A. So I'm going to use this equation. So we have 1 over U22 times A32 minus, and that summation is L31U12. Okay, so k is 1, so A32 U21. Sorry, U12. Okay, so U22 was 10. So we've got 1 over, that should have been minus 10 by the way. So 1 over minus 10. A32 is 1. Minus L31 is minus 3, so I'm going to change that to a plus. U12 is 3. So that comes out as minus 1. Okay, so I've done the first two columns, so just left to do column 3. So we have U13 is going to be just equal to A13, so that's going to be 0. We're going to have U23, so using this here we are going to have A23 minus, and now we're going to have k goes from 1 to I minus 1, so that's just going to be 1, so it's going to be L21U13, which is A23 is minus 1 minus L21 was 2, U13 we just calculated that as 0. Okay, that's quite easy, so that's just minus 1. And U33, so notice all of these, so this element here we know that L33 is 1, so we need to calculate what U33 is. So that's going to be A33 minus L31 U13 minus L32 U23. So this summation here, okay, now I is now 3, so k is 1 and 2, so we've got a couple of terms in that summation. Okay, so A33 was 2, L31 was minus 3, so I just change that to a plus. U13 is 0, minus L32, which is, where's L32 here, which is minus 1, so I change that to a plus, times U23, which is minus 1. So I've got 2 minus 1, which is 1. Okay, so therefore our L matrix is, we have a lower triangular matrix with with 1s on the main diagonal. We calculated L21 to be 2. L31 was minus 3, and L32 was minus 1. And we also had U. Okay, so we have lower triangular elements of 0. U11 was 1. U12 was 3, U22 was minus 10, U13 was 0, U23 was minus 1, and U33 was 1. Okay, so that was our LU factorisation of that 3x3 matrix. Now, the useful thing about LU factorisation is we can actually check that. So we can, once we've factorised something, we can check it. So I'm just going to write down what we just calculated. Okay, so we have 0, 1, minus 1. So that was our L matrix we just calculated, and U was this one here, and 0, minus 1, 1. Okay, so we're saying that A equals L times U. So I've got, if I want to perform the matrix multiplication, just to check that that is indeed the case. Okay, so what we got? We got 1 times 1, so that's going to be 1. I was going to say, so going across and down, so we've got 1 times 1. We've got 1 times 3, and we've got 1 times 0. Okay, so 1, 3, 0 on the top. 2 times 1 plus 1 times 0 plus 0 times 0 is 2. Okay, second row, second column, so I've got 2 times 3 is 6, plus 1 times minus 10, so that's minus 4. Second row, third column, 2 times 0, 1 times minus 1, so that's going to be minus 1. Okay, and finally, third row, we've got minus 3 plus 0 plus 0, so that's minus 3. Minus 3 times 3 is minus 9, plus 10, that's minus 1. 3 times 0 plus 1 plus 1 is 2. Okay, and if you compare that to the original A matrix in this example, you can see that we've correctly calculated the LU factorisation.